take one for the team by absorbing the harmful carbon dioxide in our atmosphere. There are three main sources of this atmospheric pollutant. The biggest contributor is electricity, as it comprises 38% of the total CO2 emissions in the United States. That's a lot. The combustion of fossil fuels, such as coal, oil, and natural gas, fuels homes, businesses, and industries. The second most generous source of CO2 is transportation, which makes up 31% of CO2 emissions in the U.S. The combustion of other fossil fuels, such as gasoline and diesel, is what makes cars, trains, planes, and other methods of transportation work. As much as we love our cars, eventually we will pay the price. Finally, industry makes up 14% of the CO2 emissions in the U.S. Industrial manufacturing of things such as plastic, cement, and metal produces carbon dioxide. Since the Industrial Revolution, the combustion of fossil fuels has contributed to a 40% increase of the concentration of CO2 in the atmosphere. With the growth of population and the creation of new technologies, emissions of key greenhouse gases have increased by 70% between 1970 and 2004.
In our experiment, 2 plastic bags were filled with a sampling of moss, blepharisma, and fresh water. One of the bags was filled with synthesized carbon dioxide, which we obtained by reacting 2.9 grams of hydrochloric acid with 9.68 milliliters of 6 molar calcium carbonate. The other bag was filled with regular air from outside. Over the course of 4 days, we took observations of the effects of the carbon dioxide on the biological components in the bag versus the effect of regular air.
2 days after the experiment was performed, we took observations. In the bag containing our synthesized carbon dioxide, all of the blepharisma was dead. The fresh water, which initially was a 7.0 on the pH scale, was now a 5.7 and was an orangey yellow color. The moss remained unaffected. 3 days after the experiment was performed, the blepharisma was still dead, the water remained at a 5.7 on the pH scale, and the moss still remained unaffected.
From our experiment, it can be concluded that carbon dioxide definitely poses an environmental threat to some living organisms. The blepharisma in our ecosystem were dead after 3 days in the CO2-filled system. Contrastingly, the moss remained in the same condition in both bags because plants regularly remove it from the world by taking it in as part of the photosynthesis process. Though it may not appear as though the gas is having an effect on the plant, it does. Through a process called evaporative cooling, plants give off water through tiny pores in their leaves to cool themselves, just as perspiration cools our human bodies. On a hot day, a tree can release many gallons of water into the air, acting as a natural air conditioner for its surroundings. The plants absorb carbon dioxide for photosynthesis through the same pores, called stomata. When carbon dioxide levels are high, the leaf pores shrink. This causes less water to be released, diminishing the plant's cooling power. This means that the moss did not provide as much evaporative cooling in the CO2 bag as it did in the bag with the regular air, which would result in the bag heating up. The blepharisma died because the carbon dioxide in the bag reacted with all of the water, forming carbonic acid, which changed the universal indicator to a bright red immediately after the carbon dioxide was added. This has negatively affected our oceans by increasing their acidity and damaging their ecosystems. If carbon dioxide posed these major threats to these 3 earthly components in only 3 days, imagine what it could do to you someday.
I know this whole time you've been just dying to know how these carbon dioxide emissions affect us and plant life. As mentioned before, CO2 limits the amount of water plants release into the air, causing our surroundings and us to heat up. And this is how CO2 emissions play a big part in the global warming process. The tragic downfall of our blepharisma affected the impact that CO2 would have on people like us and animals. The oceans of the world have absorbed close to half of the CO2 emitted by humans. This is a problem because of something called ocean acidification. When water is exposed to CO2, something called carbonic acid is formed, and yes, it is as bad as the name sounds. The carbonic acid eats away at our natural coral reefs and kills many oceanic organisms. The ocean's average surface pH has increased by 0.1, which is much larger than it sounds when you consider that this is the entire ocean that we're talking about. Carbon dioxide makes up the majority of greenhouse gas emissions in the U.S. Unfortunately, greenhouse gas emissions in Texas are the highest in the entire nation. If Texas were a country, it would rank 7th in the world in carbon dioxide emissions. Looking just specifically at Dallas, carbon dioxide emissions have skyrocketed over the last 20 years. Between 1990 and 2012, there was a 7 million ton increase in community carbon dioxide emissions and a 200,000 ton increase in city operations. The most prominent effect of carbon dioxide in Dallas is the Great Trinity Forest, the largest urban forest in the U.S., and the Trinity River. Carbon dioxide is a major source in the pollution of the Trinity River, and it has decreased evaporative cooling of the trees in the forest, part of the reason why Dallas gets so unbearably hot. Luckily, the Trinity River Project is a public works project created in order to improve the water quality of the Trinity River and to create a series of parks, nature reserves, and other recreational centers. Even though Dallas emissions are predicted to increase by over 1 million tons by 2015, there are ways we can reduce this number, and this starts with us. Use energy-efficient appliances, such as an eco-friendly light bulb. Drive fuel-efficient vehicles, such as a hybrid. Turn off lights and electronics when not in use. Reduce distances traveled in vehicles, such as walking or riding a bike. Finally, produce more energy from renewable sources, such as energy-efficient wind and hydropower equipment, and using fuels with lower carbon content, for example, ethanol, which is made from corn.